Now it's just this is the charge tape lab revisited. So pretty much it's just a continuation of lab 1. The purpose was to compare the results between lab 1 and lab 2, which meant comparing the electric force on a point charge versus on a line of charges. And we did different calculations for that through a model which analyzed the electric forces acting on the tape. And this was done through ClosScript, so it was using, coding in order to model the electric force and gravity. For this assumption, we said that the charge is measured evenly across the whole tape length, where the floating tape was the system and the surroundings were the other, tape and gravity and all that, like external forces. And then the preview of the results is down below for the numbers as well, for the point versus the line charges. Physics explained, this is the same thing that we had to use in the last lab. It's just the force of gravity equals mg, there's net force equals ma. Sum of forces is the force electric counteracting the force of gravity and then being equal to each other, because net force we assume to be 0, but obviously in this lab we will be testing that. Then we have Coulomb's law, which is also explained, and that gives us the force electric. Assumptions of the model, this is the same stuff that we used last lab as well. It's that the tape was 0.2 meters long, the density of the tape was 1 gram per meter, and so the mass was 0.2 grams. Now, lab 1 procedure is here just so that anyone can reference it if they want, but it was pretty much just charging tapes and then putting them close to each other to see the effects. Lab 1 GlowScript code. So this is the GlowScript code that we had last time, and it pretty much just, as you can see from the middle image, represents a point charge, and that's supposed to model the system here. So we had the force electric versus the force of gravity set equal to each other on one specific point, which is not the best assumption, which is why we did lab 2. So lab 2 GlowScript code, you can see that there's a lot, but essentially what it does is it takes the two tapes, it sets them to be a distance from each other, which we had inputted, and then it also decides that it's going to take different points on the line and then go off of that instead of modeling it so that it's all at a singular point. And so that's going to be represented by the image on the next slide, which is here. So like we said, we have that red line, which is the top tape, the blue line is the bottom tape. Then we have the white is the force electric, the yellow is the force of gravity, and then the green is the electric field. And so the model shows us the magnitude of the electric force to be 1.88 e to the negative 3, and the force of gravity to be 1.96 e to the negative 3, which shows us that in this assumption, in this model, they're not equal to each other. So it is different results than it was for lab 1. And like I said, this is the continuation of the code, pretty much just showing that we ended up changing some stuff within the lines in order to be able to model it as a line for the charges instead of a point, and separation distance between the different tapes. So some of the calculations also done were the force of gravity to find 1.962. Then we used that, plugged it in, set it's equal to the force electric, and so from that we could solve for Q, and that's what we got. So the possible errors in this lab were that only two forces are assumed to take place, and that's gravity and the electric force. We assume that the charges of the tapes don't really vary, but usage throughout the lab originally could have caused differences in their charges. Also, wind or, any sort of external force could have caused some effect on the data that just wasn't accounted for, and it's possible that the charges were also not fully uniformly distributed. Now, for what if and what does it mean? So what if you modeled each of the tapes as a single point charge like in the previous lab, and then estimate values for charges? So yeah, that's pretty much what we ended up getting. It was the 7.379 times E, to the negative 9 coulombs for a point charge. And you can see a very, very big difference for the charge that we get from a line. And that's just because these are different models with different assumptions, and so it really does produce a big difference. As to why these estimates differ and which one's closer to the real one, like we said, different calculations and generalizations, just because instead of modeling it as a single point, you're modeling it as a line. And the line charge is closer in value just because it models a greater area, which is what the charges would be like.